We're well familiar with the idea that conduit and trunking come in two broad material categories, plastic and steel, and that cable tray is generally made out of steel. But this is to overlook an incredibly useful form of containment material, which is GRP, or glass reinforced polyester. Now, straight off the bat, you're probably hearing that and thinking it's a contradiction in terms. How can glass be a reinforcement, and isn't polyester a fake silk fabric? And you're correct. We know from personal experience that glass is incredibly brittle and polyester is soft and flexible. Neither of these properties are going to be much use for sturdy cable containment in challenging environments. However, thanks to the miracles of chemistry, mixing two different materials in the right way to create what's called a composite can combine the best qualities of both. A good example is steel reinforced concrete. Concrete by itself shows incredible strength when it's being compressed. It won't easily give way if something is pressing concrete into itself. If, however, you apply tensile force to concrete, in other words, try to draw it away from itself, we find that concrete will crack at much lower levels of force. So by adding lengths of thin steel rods into the concrete, we introduce the high tensile strength of the steel into the mixture. This means that the resulting material has the compressive strength of concrete and the tensile strength of steel, making for a more robust material that can be used across a wider array of applications. Also, keep in mind cumulative strength, the principle that if you take one piece of a material, like this dry spaghetti, it's really easy to snap. If, however, I get a bunch of it together, it gets much harder. My apologies to the entire Italian community. So what do concrete, steel and Italian pantry staples have to do with GRP cable containment? Well, just before we answer that, if you're watching this video on any of our social media accounts, click the link in the description to view it as part of our free training package to help you with your CPD and receive a certificate. If you're already watching it as part of that training package, then your genius will shame the intelligent. Let's crack on. The interesting thing about glass is that if it's spun out into long lengths, it actually has pretty high tensile strength. And as for polyester, depending on how it's made and cured, it can become a stiff material that has pretty good compressive strength. So already we've got the makings of a pretty sturdy material when we combine these two materials together. Also, part of the intricate process of making GRP containment is to arrange the glass fibres in layers, so that one layer runs in a given direction and then the next layer runs at a right angle to the first and then back to the original orientation for the next layer. This means that whatever direction tensile force is applied to the material, it retains its strength. So in reality, GRP is a really good material to make cable containment from. It can outperform PVC containment in terms of how much cable it can hold and also the required distance between supports. PVC cable trunking or tray tends to be limited to light duty applications as PVC can sag under heavy cables or soften at moderate heat. GRP, reinforced with glass fibres, has mechanical strength closer to metals. For instance, GRP ladders can support large cable bundles in industrial settings similar to a steel ladder. In terms of impact resistance, metals will dent but generally hold integrity. GRP is resilient, meaning it won't permanently deform easily, but a very sharp impact can crack or chip it. Overall, for heavy duty requirements, steel and GRP are suitable, with steel having a higher absolute yield strength and GRP having sufficient strength with added benefits, which we'll talk about in a moment. Whereas PVC is not usually used for heavy loads. GRP also maintains strength across a wide temperature range from -80 degrees C to +130 degrees C. That's a much better range than PVC, which becomes brittle in the cold and softens with heat. It's also a winner when it comes to weight as well. GRP containment products can weigh as little as 40% of the equivalent steel. This means less physical strain on the installer and reduces the chances and consequences of accidents when it's being moved around. When it comes to smaller cable trays, this difference is not that big a deal, but when you start dealing with cable ladder for heavier cables, the steel-based frames become extremely heavy and require suitably sturdier supports and fixings. The GRP equivalent, though, is much lighter. And while it's important to make sure that the fixings are capable of supporting the cables and the containment, the GRP ladder containment adds much less weight to the total load. Another area that requires careful thought with containment is cutting the sections to the right lengths. Cutting through steel can be done with a hacksaw or a power tool. The challenge with cutting steel is that if you do use a power tool, it can create sparks, meaning that for most construction sites, this is then classified as hot works, and you may need to get a permit to work or cut it off site. GRP containment does not have this issue as it won't produce sparks when being cut. However, as with cutting all materials on site, cutting GRP will produce tiny particles that will be harmful if inhaled. In this case, some of those tiny particles are the glass fibres used to bind the GRP together, and you really don't want to be breathing those in or getting them in your skin or eyes. We've all crawled through fiberglass in lofts and massively regretted it. So you take the usual precautions in the hierarchy of risk control, using dust extraction where possible, and always wearing relevant PPE like gloves, goggles and a dust mask. GRP has other benefits over steel as well. It's much lighter, meaning it's easier to handle and will put less strain on your back and other areas of your body when you're moving it and installing it. It's also non-conductive, which means that it can't experience heating via eddy currents, and you don't need to worry about whether or not you should bond it. In most instances, you don't actually need to bond steel cable tray or ladder either, but that's still quite a controversial subject for most electricians in a completely different video. It also performs really well in a fire. Because GRP is a composite, the resin can burn, but Marshall Toughflex GRP is formulated to be self-extinguishing and low smoke with no halogens. In a fire scenario, GRP will char and self-extinguish, limiting flame spread. It also doesn't emit the dangerous gases that PVC does. GRP contains no chlorine or halogen, so it won't produce HCI or dense toxic smoke. Also, GRP has a low thermal conductivity relative to metal. It doesn't rapidly conduct heat or get as hot to the touch as metal does in a fire, and this could potentially slow the heat transfer to cables or walls in a fire, and also means that if there is a brief flame exposure, GRP might protect cables longer than thin steel, which heats up really quickly. But probably the area where GRP containment absolutely outperforms all of the materials is its ability to resist corrosion. Steel must be properly protected to avoid corrosion. Indoor galvanized steel works fine in mild environments, but in any damp or aggressive environment you need hot dip galvanizing, powder coating or stainless steel to prevent rust. Even then, coatings can scratch and rust over time, and stainless steel, while corrosion proof, is very expensive. Also, every time you cut galvanized tray, you need to treat the end with a galvanizing spray to prevent corrosion. GRP is inherently corrosion resistant, it will not rust at all, and it withstands moisture, salt, most chemicals, and UV exposure without additional coatings. And when you cut it, the ends require no special treatment whatsoever. So there we go. That's our introduction to GRP containment. If you're watching on our training platform, then answer the multiple choice questions that follow and move on to the next video. If you're watching on one of our social media channels, then click the link to move over to the free training package and get yourself a certificate. Or you can watch the same video in the series right here to find out where we use this type of containment. All that remains in this video is to say thank you very much for watching.